In this video, we're going to look at composition functions. So compositions of functions. So at the top of the page, we can see we have f of x, g of x, h of x, and j of x. And on example 17, they want us to find j of 1. So you're always going to start with the inside. So j of 1 means that I'm going to look at the function j of x, and every time I see an x in j of x, I am going to replace it with a 1. 1 cubed is 1, 1 squared is 1. 1 plus 1 is 2. So now I'm going to take this answer and I'm going to evaluate the outside function with this answer. So I am going to find j of 2, because that outside function right here is also j of x. So this means that every time I see an x in j of x, I am going to replace that number with 2. 2 cubed is 8, 2 squared is 4, 8 plus 4 is 12. Let's try that again on example 18. So for example 18, we have g of 10. So I'm going to start off by finding that inside function, which is g of 10. So again, I'm going to be looking at the function g of x. Every time I see an x in g of x, I am going to replace it with 10. 2 times 10 is 20. So I'm going to take what g of 10 equals, and I'm going to plug that into my outside function, which happens to be g of x. So every time I see an x in g of x, I'm going to replace that with a 20. 2 times 20 is 40. Let's look at example 19. On example 19, I want to find h of x. So I'm going to start with that inside function. My inside function is h of x. If I look back up at the top here, h of x is 3x minus 2. So I'm going to take what h of x equals, and I'm going to plug it in to the outside function. My outside function is h of x. So every time I see an x in h of x, I am going to replace that with what h of x equals, which is 3x minus 2. 3 times 3x is 9x, and 3 times negative 2 is negative 6. And I'm going to bring down this negative 2 here. From here, I can combine like terms. Negative 6 minus 2 is negative 8. So h of x equals 9x minus 8. On example 20, my inside function is f of x, which equals 16x squared minus 1. And I'm going to take this, what f of x equals, and I'm going to plug it into that outside function. That outside function is f of x. So every time I see an x in f of x, I'm going to replace it with 16x squared minus 1. So when I look at this, here I have 16x squared minus 1 raised to the second power. Remember that means, 16x squared minus 1 squared. This means 16x squared minus 1 times 16x squared minus 1. To multiply a binomial by a binomial, I have to use the area model. So 16x squared times 16x squared is 256x to the 4th. 16x squared times negative 1 is negative 16x squared. Negative 1 times 16x squared is negative 16x squared. And negative 1 times negative 1 is positive 1. So right now, I have this 16 that was out in front times, and then if I look inside my area model, I have 256x to the fourth, negative 16x squared minus 16x squared is negative 32x squared. And then 1 doesn't have a like term, so I'll bring that down. And then I still have this negative 1 that was on the outside. My next step is to use a distributive property. So let's see. I'm going to grab my calculator. So I have 16 times 256, which is 4,096 x to the fourth. 16 times negative 32 is negative 512x squared. And 16 times 1 is 16. Remember that you still need to bring down this negative 1. My last step is going to be to combine like terms. So I'll have 4,096 x to the fourth minus 512 x squared, and then 16 minus 1 is 15. This would be your answer in standard form.